Welcome back to the SDG stage for this afternoon's talk about decoding the human immune system. So I'm very pleased to have here in Geneva today two fantastic speakers. So I would like to now introduce you to first Dr. Hans Keirstead, who is the CEO of the Human Immunome Project and an internationally known stem cell expert.
Thank you.
And I would also like to call on stage Mrs. Jane Metcalfe, who is the founder of Wired magazine and also the founder of proto.life more recently. Over to you.
Great.
Thank
you so
you.
much. Thank you. Hi. So, yes, I am Jane Metcalfe, and I'm here in two capacities. One as the editor and founder of Proto.life, the other is chair of the Human Immunome Project. So I'm wearing two hats today. But 30 years ago, my partner, Louis Rossetto, and I started Wired magazine to cover the extraordinary developments at the leading edge of digital technologies. And now 30 years later, I've started Proto.life, which is what I consider to be the next stage of the digital revolution, or also known as the neo-biological revolution, which is when we take the extraordinary tools of the digital age and apply them to engineering human biology. So the neo-biological revolution is the forefront of neuroscience and genetics and synthetic biology. It's the future of food. It's many different technologies. And we look at the scientific papers on a weekly basis and give a little synopsis of them and why they point the direction of where we are going as a species. And we also include feature stories. So if you're interested in that, want to follow along at home, you can sign up, but you have to go to www.proto.life because .life is a cooler domain name than .com. So 20 years ago, we sequenced the human genome, and that unleashed a torrent of scientific innovation and discovery and medical innovation, which continues to this day. We now have the ability to prevent monogenetic diseases and to address diseases caused by genetic mutations. That work will continue. Those innovations will continue for many years to come. But the human genome only represents 20% of human disease. The other 80% is going to require us to unlock the mysteries of the human immunome. So we have launched, as of October of last year, the Human Immunome Project, which is a global NGO, a consortium of academia, industry, government, and NGOs with an extraordinary moonshot mission to use the technologies, including artificial intelligence, to build models of the immunome. When we do that, we anticipate unleashing a torrent of innovation leading to new diagnostics, new therapies, new vaccines, with ultimately the goal to help anticipate who is going to respond how to which immunological threat, a threat being a pathogen, a vaccine, or some process within your body that's out of control, autoimmune diseases or cancer, what have you, with the ultimate goal of delivering the right therapy to the right person at the right time. So let me just figure that out. As you might imagine, there's quite a few obstacles that we will confront along the way. One of them, which I think is really important to realize, is that low and middle income people and countries experience an undue burden of poor health and disability. And so far, advanced research is typically done on grad students and people of European descent. And so bridging the North-South divide and really understanding the human immunome is going to require us to collect data from diverse populations around the world over the course of time. Another big issue, and this is not less important or consequential, is silos. So, we're here at the United Nations, and I'm presuming that pretty much everyone in this room is a multilateralist. But, taking it down at the individual science level, there's very little incentive for science to share data. There's little opportunities for academics to share and collaborate with industry, for industry to share and collaborate with governments, and for governments to share and collaborate with NGOs. We all know this is a problem. It's further exacerbated by the fact that even within science, even within the field of immunology, there are silos. The microbiologist doesn't know what the neuroscientist is doing, and the geneticist doesn't know what the nutritionist is doing. And so these silos, as you get deeper and deeper into your expertise, the silos get, of course, taller and taller, and the collaboration more and more difficult. So if there's anything we've learned from the digital revolution, is that we are going to have to figure out how to be an expert in one field and a neophyte in another, or eventually accumulate multiple fields of expertise so that we can solve today's problems, because that's what's going to be required. You can no longer stay in one silo and solve the world's challenges. So we have the north-south divide, we have silos. And the third issue, goes to really the heart of what we're talking about here, which is the sheer complexity of the human immunome. It's not just the sum total of the molecules and the cells and the tissues and the organs. That would be a mapping exercise. And essentially, that's what the study of immunology has been up until now. It's like, well, here's my T cell, and that's how this works, and here's my B cell, and that's how that works. But if there's one thing we understand now, the immune system is much more complicated, and it interacts with the other systems in your body, and all of that interacts with things external to your body, like stress, pollution, and other elements of your environment. So really, the way to think about this is as a complex system. So it's not cartography, it's complexity science. And the only way forward with that is with AI. So biological data is apparently extremely inspiring to AI leaders. And we are also in the life sciences sort of uniquely positioned to take advantage of what AI has to offer us right now. So with that, by way of framing, I want to introduce my colleague, Dr. Hans Keirstead, who I could go on at great length about what a rock star this guy is. I met him through editorial channels initially, and then ran into him again at a longevity conference. Started out life as a neuroscientist, stem cell pioneer, figured out how to make 99.6% pure stem cells, oligodendrocytes, actually.
Nice.
And thank you. Parlayed that into 3 successful biotech exits and 2 more that he's currently running. And then in his spare time, he advises 14 different world governments and he's a total regulation nerd. Anyway, as soon as and I forgot to mention, he helped raise $8 billion for the state of California to launch basic stem cell science research in his spare time. When I met him, yes, thank you. Thank you. When I met him, I was like, I'm going to keep track of this guy. The second time I saw him, I asked him if he would join the board of the Human Immunome Project. At his first board meeting, we said we were going to do a CEO search. At his second board meeting, we said, guess what? It's you. At his third board meeting, which was literally last week, he presented a strategic plan for this incredible moonshot. So when I say rock star, I'm really not kidding. And so, Hans, what made you decide to basically completely prioritize your life and come be CEO of the Human Immunome Project?
Well, from a personal point of view, it was really, just a driving passion of mine to help people. And I feel very grateful that I've been able to do that in several different ways. Scientist and drug developer, policy maker, and running charities.
Cool.
Secondly, it's why. It's the why now. It just struck me when I started working with Jane in the Human Immunome Project that this is precisely the right time for a mission of this global reach. Just in this year alone, we've seen unprecedented developments in biology, like single cell protein and genetic analysis and manipulation, like the omes, now being driven down to extremely inexpensive and accessible platforms. Several things like that facilitate this work now. Immune organoids, another one. In the AI space, we're seeing things like, just fast-tracked LLMs. We're seeing amazing algorithms for protein folding. We're seeing, I think it was just February, the importation of pictographic inputs rather than just simply text inputs. So it's a confluence of events that are happening right now that made me think we can do this.
So 5 weeks on the job, he presented his strategic plan, and I'd love it if you would tell us how we're going to get there.
Okay, this is easy. So what I started doing was when I took over the CEO position of Human Immunome Project, I made phone calls alone with one very good scientist beside me who was actually an immunologist. I'm a neuroscientist, not an immunologist. But Scott Graylick and I interviewed 50 of the world's leading immunologists, and that was a very, very insightful start. What is the mission? What is the global mission? Of course, we had an idea. And what is the means in which we are going to affect that global mission? What's the study protocol? Think of it as like a 2,000-page materials and methods section of the world's largest immunological project. And what was really very heartening is that every one of those individuals said yes. Several of them had word tweaks and some changes that were very substantive to our protocol. But together, we came up with a mission and, most importantly, and much more usefully, a very detailed study protocol of how we're going to affect this. So this is the mission you see behind you. We're generating immunological baseline and functional data sets. And functional data sets means how you're responding to a challenge, whether that be a vaccine or a pathogen, whether that's an immunotherapy, autoimmunity, a challenge to see where you go from when you're baseline to a response. And with those two bits of information, we can really throw a series of investigations at that standardized baseline and functional in every human population. So we are looking at all ages, all ethnicities, all socio-economic classes, because your immune system changes dramatically if you're poor or if you're wealthy, for several very good reasons that shouldn't exist, but they do. Of course, both sexes, but also genders. We're going to have to do some prioritization here, of course, to hit the larger markets first. But all of those things using a set of very standardized probes. These are just a sample of what we're going to do. So we're going to throw the 6 typical ohms at multiple organs in the human body of all of those individuals. And what we're trying to do is have an outcome that's of use to every stakeholder, which is researchers, patients, drug developers, and leaders of countries. So with these types of ohms and several others, like for example, organoid development that's going on right now, not yet standardized like these ones are, but we are looking at standardizing those newer emerging tools and looking at these in a number of populations. So if you see 6 data sets and 30,000 data points, and then you layer on top of that, as this next slide shows, all of the, for example, subgroupings of human populations that we're going to be looking at, you have a mere 1.9 trillion data points.
So people are always asking this. This is the first question when we tell them what we're going to do is like, where's the data going to come? What format's going to be in? How are you going to protect it? What are the privacy and so forth issues? So how are we going to get this data and how are we going to flow it into our models?
Yeah, it's we're going to basically develop AI models that we're doing right now. If you hit the next slide, we're doing this in 2 stages. The first stage we're calling Engine 1.0. And you can think of this as a prototype, where now that we have a very precise study protocol, we know all the populations, we know the data that we're getting. That means tagging. So we can tag existing literature, but we know that that is imperfect, right? It's imperfect. Maybe we can't get the raw data behind it. Maybe we can't really import that graph. Maybe that research was retracted or should be retracted. Maybe it can't be repeated. There's a lot of difficulties in going to existing work. There's going to be some beautiful wins, like that first engine's going to have a very, very complete data set on Black women in South Africa challenged with AIDS, where that study was done extremely well, tagged extremely well, showing before and after getting AIDS, who got it, who didn't, that a cervicovaginal mucosa had a different microbiome. Well, that's a druggable target. That's the kind of thing that we are going to be hitting hard. So that would be great. Other aspects that aren't so well developed and well tagged are going to be poor. But this prototype is going to allow us to have a model that individuals, all stakeholders, can poke and prod and play with and help us develop. And that leads us to our second model, which is Human Immunome Project sponsored data, where we are paying thousands and tens of thousands of immunologists all over the world to conduct our precise studies. And of course, obtaining the data in an AI-friendly, formatable manner. We're also working with governments as another way to get this data from the top down. Rather than researcher to researcher, I have been approaching leaders. I just came back from 2 countries where we have agreements to share data with the governments. So that means I can now take that, Human Immunome Project can take that agreement to every institution within that country, research organizations, their CDCs, their FDAs, and say, let's share, because your leaders said let's share for very good reasons. And we're investigating as well privacy issues. You can de-identify data, but AI is good and it can re-identify data. But there are several individuals in the world and groups in the world and institutions that are working very, very hard at how to work with that data in order to prevent it from being re-identified, like mass compartmentalization of statistically significant numbers that are binned. So all my genetics are over there and all my proteome data is over there, mixed with 10 million other bits of proteome data, so it's harder to tag. So the second generation of this engine is going to be extremely sophisticated, very well tagged, and obtained within years, not decades, because we've got the tools. Human Immunome Project, 10 years, $2 billion, 8 years to develop tools, 2 years to get the data. We've got the tools. So this is going to move.
Exactly. So a lot of people are building AI models now. What was I saying? Where am I? So Amazon, for instance, is tracking all sorts of data that could be useful to our immunological models. Governments are tracking this, insurance companies tracking this, hospitals are tracking us. What is it about the human immunome that supersedes that? What makes it different?
A researcher is looking at a very precise problem with very precise tools. A drug developer in the immune field is looking at an indication. Generally, drug companies are indication specific. Companies are looking at bottom line and revenue. So they all have focus points. The Human Immunome Project has the good fortune to be able to pull themselves up into more expanded global focus, where we are actually accumulating baseline data on every single human population. So what we are providing is human immunological baseline data to every stakeholder. So if you're a patient, you will use these engines to say, I'm a 42-year-old female and I was just prescribed this. Is it the right drug? Is there an alternative? Was my doctor good enough to prescribe the right drug? If you're a doctor, you can look into this engine and say, I just prescribed this drug to this particular individual. What contraindications should we be looking for because of his or her race, their socioeconomic status, their background, their baseline immunological state of autoimmunity or cancer or healthy? If you're a drug developer, you can look into this data set and say, wow, black 55-year-olds have extremely high autoimmunity, more than most other races and most other ages. And because we have layered onto the science full business development analytics. So this is landscape analysis, competitive landscape of competitors. This is every other drug going at what timeline, so you can actually tell, is your drug going to be rendered futile in a phase 3 because there's another standard of care that's going to change, making you repeat a phase 3? So that full set of BD analytical tools layered on top of science allows drug developers to just probe what's a new personal medicine that has a sizable market that allows drug development that is refined. And then lastly, country leaders. So country leaders, ministers of health, presidents, rulers, prime ministers, they can use these tools in order to say, what is my country's demographics? What are my problems? How old is my population? What race? What socioeconomic status? What drugs should I be buying and importing rather than having my doctors prescribe inadequate drugs for my particular population? And how may I interact with leaders around the world in order to use this system to lower healthcare costs?
Great. So we're on the SDG stage, and we've been asked to translate all of that into SDG goals. And that was the best part of preparing for this, I got to say, because
Yeah.
it's like, there's a lot. So we broke them down into 4 categories: good health and well-being. I can't read the slide. Industry, innovation, and infrastructure, reduced inequalities, and partnerships for the goals. But within all of these, there are subgroups, and it is astonishing how much opportunity there is for this project to advance the science, moving from cartography to complex systems thinking. We are creating global consortia. Countries are looking for reasons and opportunities to collaborate with other scientists in other countries. We're going to be promoting data standards and data sharing practices. We obviously will be working to close the health disparities that exist between the global north and south. And we're going to accelerate our progress towards true precision medicine. The genome, again, is only 20%. The immunome, you can't achieve precision medicine without decoding the human immunome. So, Hans, what do you hope to accomplish here at the conference?
The Human Immunome Project is looking for AI partners because we are getting data now, and now we need to import it and build the engine around it. And we've started that process, but we're looking for AI partners to help us with that iterative process as both the AI changes as well as our data sets expand. We're looking for quantum computing partners where we can actually focus in on more focused data sets that have an unfathomable amount of variables. We're looking for data partners, both to share and move data around, but also regulate that so we can use best practices on a global standard and set that standard. And then lastly, we're looking for country leaders, and we are knocking on their doors right now in order to step up and begin a global sharing data mentality around the world where they are responsible for taking the first steps to uniting all of the stakeholders of health within their countries with those of adjacent nations and nations all the way around the world in order to, affect the saving of lives and the decreasing of that some 20% of one's GDP, no matter what country you're in, that small savings there can have a tremendous effect on one's economy and this better standard of living for everyone.
So we didn't go through the long list of institutions and impressive scientists that are already associated with our project, but one of the key members of our scientific leadership group is Stuart Russell, who's here in the front row, and we're deeply grateful for his expertise. But this is bigger than any one immunologist or any one machine learning expert. This is bigger than any one pharmaceutical company, and this is bigger than any government. So this really is the only way to move this forward. And we have signed up some of the most extraordinary partners. And if you have any connections, suggestions, or others, please let us know. This is how you can reach Hans. This is how you can reach me. Our website is being rebranded, and we're not there yet, so it's kind of there. But you can see some of the science that we've already done, some of the researchers we're already collaborating with. And then just please, keep track of what we're doing, because we're going to change medicine. Thank you.
Thanks, everybody.
So I was told if you have any questions, we might have 60
Yeah.
seconds. Okay.
Yeah, we can take a few questions. Okay, I saw you first, so.
Yes, thank you so much for the very interesting talk. Can I ask a quick practical question? What stage is your data collection effort? Are you in a position to share with researchers, postdocs out there in the world?
Yes, like we have sponsored immunological projects over the last couple of years, for which we have publications and all the grant applications that went into that, et cetera. So certainly that's a very good start. It's over this next 2 years that we're actually moving out into the AI pull. So the data that's actually tagged for machine learning. And so yes, this is all open source. Like this is a not-for-profit where everyone will have equal access to it.
You can go on our website under science and you'll see the projects. There's AIDS, young women with AIDS challenged by COVID in South America, South Africa. There's a maternal and newborn immunity project in Australia, and a collaboration with the Chance School at Harvard on the immune systems of the elderly. Plus the B cell and T cell repertoire. Sorry, I
Yep.
just realized
There's a
that's
ton
not
of
all of
data.
it. It goes on.
Yeah.
Yeah, a great speech. Thank you. So, two questions. First question about two questions about global sharing of health data, because I think it's really the central question. The first one is normally there is a beautiful project at the European level called the European Health Data Space. I think the goals are really great, sharing of health data for scientists, not for commercial reasons and so on, but it's going pretty slow. So what do you think about this project? And second question, just a few miles from here, in France, about 50% of the citizens, they give their health data without even knowing it to a big company called IQVIA. And this is for commercial reasons, but not for, let's say, sharing health data. How is this possible, and how can you work to change this situation? That citizens, in place of giving their health data to private companies, would give it to everybody to progress for science.
Well, I'll take a stab at that. You know, what you've said is very exemplary of the situation right now, in that there are several institutions out there doing wonderful jobs of collecting data. You know, UK Biobank is doing a phenomenal job of longitudinal immune data, and several other things besides the immune system.
Using informed consent.
Yeah, right. Because yes, using informed consent. There are other groups that are for profit with their own particular focus that are abusing rules, basically collecting data without informed consent. You know, the Human Immunome Project is setting international standards on this. So we will be providing guidelines as we pen it with more and more nations that provide an ethical basis for data sharing, that aren't stealing patient data, but rather using consented patient data in a manner that we're actually paying for. The Human Immunome Project pays for this data. Like, we are actually receiving money from several sponsors, and we are paying institutions to do the research, and they're doing that research under proper IRB consented controls. It's a very transparent, open system rather than the siloed institutes that you referred to.
Yeah.
We'll take two more questions.
Hi, thank you for a great talk. I'm a physician from the US, and I have one, or actually two questions. The first is, it is my belief that at the center of health should still be the physician-patient relationship. Do you still envision that, and how does that fit into your project structure?
I'll answer
And
that
then-
first then.
Okay,
And then you can answer your second one.
okay.
Absolutely. You know, Watson was a good case example of that, where a whole bunch of advisory data and diagnoses were done on a computer. But that really underscored, you know, back when that happened, the difficulty and the divide between who controls the diagnosis and the prescription and the follow-up of the patient. And I think what we learned from that is absolutely positively the physician. So this is a tool that both the patient and the doctor can look at, both of them. So it ups the bar, because the patient's going to be knocking on the doctor's door saying, wait a minute, how come you prescribed that drug? Because this tells me there's five other ones, and I'm a woman of 42 years old, and I might have these indications. I'm premenopausal, I'm postmenopausal, my immune system has changed because I just learned that on the Human Immunome Project site. Have you considered that? So I don't consider that to be a problem at all. I think that's good, back and forth between the patient and the doctor. But it also provides a tool for the doctor in order to do their job better, in order to check, double check, get current. So I don't think this in any way, shape, or form challenges that patient-doctor relationship. We certainly want to protect that. In no way will we ever put forward the thinking that anyone should diagnose themselves using this tool.
So then the second question and follow up to that, as you've mentioned, precision medicine. I'm an educator in the US, or I have been until a year ago. I can guarantee that within a very prestigious institution where I've trained students, if 5% of students, staff, and academics alike are aware of the term precision medicine and regenerative medicine, that would be a high number. So what is your sense or intuition on how everything that followed after the mapping of the human genome is going to be integrated into the curricula of medical schools so that, in fact, doctors can remain at the center of the physician-patient
Yeah, it's a very good point.
relationship?
You know, I completely agree with what you're getting at there. Like, I do think that the the field of immunotherapy, for example, was virtually unheard of very short while ago, and now it's right at the forefront. We say immunotherapy, companies are using the word immunotherapy. They're using the word artificial intelligence just to increase their marketing rather than true. So, but the reason that it can get in there is because it's got a real basis to it. There is something to AI, and the world's going to be shocked over the next few months alone, every few months thereafter. There are major advancements coming in medicine. The Human Immunome Project as a tool is truly an unprecedented logarithmic advance in accessibility of immune data. It really is, to everyone from the deepest immunologist who has this view, because they have to be that good. But in order to take 40,000 of them and get this view, it takes a different crowd. Well, it takes a crowd. So I think that my answer to your question is usefulness. It's the utility of the tool that's going to drive its incorporation. And if it's not useful, there's no amount of marketing that should ever be thrown at it to try to push that thing. It's either real or it's not. And this is just irrefutably a worthy project that needs to be done as it becomes iteratively accessible to the public and drug developers and nations. The utility is going to be very much akin to AI.
I think also as a science communicator, that's our job, is to take those breakthroughs and take those lives saved using a new way of thinking and make sure that everybody hears about it. And if the physicians aren't changing, the patients will demand change. And I think there's going to be so many stories. There are already, of solving cancers because we sequence the genome of the patient and the genome of the tumor. There's so many things happening that are disrupting sort of medicine as it's currently practiced. I think, hold on to your hat, Bessie, because for the next 10 or 20 years, there's nothing but disruption heading your way.
We will take one last question if you allow. Yes.
What you do should have been a prime task to WHO, but WHO wants to look good in the eyes of the civil society and the medical corps, so they feel very uncomfortable with data collecting. But you had surprisingly to come to ITU to speak.
Yeah.
So will the next war of religion be between ITU and WHO?
I've got a quick answer to that one is,
And I've got one too.
we're going to make you look pretty no matter who you are.
Oh, well said.
This is a great data set. You can use it however you would like to.
And I would just say that the former chief science officer for the World Health Organization is on our scientific advisory board.
Yeah.
And the current chief science officer of the World Health Organization is well aware, because when he was the chairman of the Wellcome Trust, we were here in Geneva 6 months ago announcing that we were doing this project. And so he is now the chief scientist there. So we are working all the channels to make sure we get the support we need. I'm going to leave the rest of that bureaucratic infighting to those of you who are going to tackle that.
Well,
Wow.
Jane, Hans, thank you so much for the very insightful talk. And thank you to our audience for your
Yes,
great
thank you.
engagement.
Thank you all very
Thank
much.
you.